Hello learner, I am Dr. Purnima Tiwari, Assistant Professor of Mathematics, Department of Science, the Bhopal School of Social Sciences. This is the second video for the module double integrals and you must view previous video. Let us recall double integral of function of two variable if A is a region bounded by two curves f1x and f2x and two straight lines x equal to A and x equal to B. Then this double integral is given by integration A to B, f1x to f2x, f of xy dy dx. That is, first we will integrate with respect to y and then with respect to x. In this video, we will solve some examples based on this concept. In this example, we will double integrate this y for the limits 1 to 2 and 0 to 3y. To this integral, we will write integral 1 to 2 and the limit of second integral are from 0 to 3y. That is, they are function of y. So, first we will integrate this with respect to x and then we will integrate with respect to y. Now, when we integrate it, this limit will as it is. Now, integration of y with respect to x, so y will deal like a constant, the integration will be x for the limits 0 to 3y and this integration is with respect to y. Now, when we apply limits, this value will be integral 1 to 2, we will get 3y square dy. Now, we will integrate this quantity 3y square with respect to y, we will get 1 by 3y cube, limits are 1 to 2. So, this integral will be equal to 3 of this quantity and when we simplify it, we will get 2 cube minus 1 cube, that is 8 minus 1 and it is equal to 7. Now, the value of this integral 0 to 1, 0 to 3y, y dy dx is 7. That is our answer. In next example, we will integrate this quantity x square plus y square with respect to x and y. So, this integral we can write integral 0 to 1. Limits of second integral are 0 to 2x. Now, the limit are function of x. So, first we will integrate with respect to y. So, we will integrate this function first with respect to y and then with respect to x. Now, this integral is 0 to 1. When we integrate x square with respect to y, we will get x square y and the second function will be y cube by 3. Limits are 0 to 2x, integration with respect to x. Now, when we apply limit, first we will apply upper limit. So, in place of y, we will write 2x. So, here we will get 2x cube and from the second term we will get 2x whole cube upon 3. Lower limit is 0. So, we will get 0 and this would be dx. Now, the value of this integral is 0 to 1. 2x cube plus 8x cube upon 3 dx. And now, when we add we'll get integral 0 to 1 14 by 3 x cube dx. 14 by 3 is constant. So, we'll integrate only x cube with respect to x for the limits 0 to 1. So, now this 14 by 3 as it is, integration of x cube is x to the power 4, we'll apply the limits 0 to 1. When we apply this limit, we'll get 14 by 3 into 1 by 4. And on simplifying, we'll get this value 7 by 6. Thus, value of this double integral is 7 by 6. That's our answer. Next, we'll solve this double integral for the function 1 by x square plus y square. To this integral, we can write integral 1 to 2. Now, limit of second integral is function of x. That is, first we will integrate with respect to y and then with respect to x. So, we'll get integral 0 to x 1 by x square plus y square, first with respect to y and then with respect to x. To integrate it, we will apply this formula integral 1 by x square plus a square with respect to x is 1 by a tan inverse x by a. So, this integral will give us integral 1 to 2. When we integrate with respect to y, this x will deal like a constant. So, value of this integral will be 1 by x tan inverse y by x, limits are 0 to x and this integral with respect to x. Now, when we apply limit, this 1 by x will as it is. When we apply upper limit, we will get tan inverse 1 minus tan inverse 0 and the integration is with respect to x. Then we will substitute values of tan inverse 1, it is pi by 4, and value of tan inverse 0 is 0. So, value of this integral will be integral 1 to 2, 1 by x as it is. In place of tan inverse 1, we will write pi by 4. This tan inverse 0 is 0 and the integration is with respect to x. Now, this will give us pi by 4 is a constant. We integrate 1 by x with respect to x. So, we will get log x and the limits are 1 to 2. When we apply limit this pi by 4 as it is, first we apply upper limit, we will get log 2 and then we will apply lower limit, we will get log 1. We know value of log 1 is 0. So, this integral is pi by 4 log 2. Thus, we get value of this integral is pi by 4 log 2, that's our answer. Next, we will solve this double integral for the function x. Now, to this integral, we can write integral 0 to 2. We observe that limit of this second integral is function of x. That is, first we will integrate with respect to y and then we will integrate with respect to x. So, we will get integral 0 square root of 2x minus x square, function is x, first integration with respect to y, then with respect to x. Now, this limit as it is 0 to 2, when we integrate this x with respect to y, x deals like a constant and we will get y limit from 0 to square root of 2x minus x square, and that integration is with respect to x. Now, when we apply limits, we will get 0 to 2 x multiplied with 2x minus x square, lower limit is 0 and this integration is with respect to x. Now, to solve this integral, we have to change this term in perfect square. So, when we change, this integral will be 0 to 2 x as it is, and value of this integral is 1 minus x minus 1 square dx. Now, we will solve this integral by substitution, and we will substitute this term x minus 1 equal to sin theta. So, we will take x minus 1 equal to sin theta. It means dx is cos theta d theta. Also, we will change limits. When x equal to 0, we will substitute here, we will get minus 1 is equal to sin theta. It means theta is equal to minus of pi by 2. And when x equal to 2, we will get 1 is equal to sin theta. It means theta is equal to pi by 2. On substituting these values, value of x will find by this relation and x will be 1 plus sin theta. So, limits are from minus pi by 2 to pi by 2. In place of x, we will get 1 plus sin theta, square root of 1 minus sin square theta. In place of dx, we have cos theta d theta. That is, this integral is minus pi by 2 to pi by 2, 1 plus sin theta, square root of 1 minus sin square theta is cos square theta multiplied with cos theta and d theta. Now, when we have to solve this term, it will be minus pi by 2 to pi by 2, 1 plus sin theta as it is. Square root of cos square theta is cos theta multiplied with cos theta, that is cos square theta d theta. Now, we will separate these integrals, integral limit minus pi by 2 to pi by 2. When we multiply 1 with cos square theta, we will get cos square theta d theta, and the second integral is minus pi by 2 to pi by 2 sin theta cos square theta d theta. Now we observe that this sin theta is odd function, this cos theta is even function, and multiplication of one odd and even function is odd function. And we have this formula that if we have this integral minus a to a fx dx, this integral is 0 and we have a formula that if we have integral minus a to a fx dx, then this integral is 0 whenever this function fx is odd, and value of this integral is twice of 0 to a fx dx whenever this function fx is even. Now, when we apply this formula, this term is integral of odd function. So, value of this integral is equal to 0. And now, value of this integral will be twice of 0 to pi by 2 cos square theta d theta by using same formula. That is, we will get twice of 0 to pi by 2 cos square theta d theta. Now, you may solve this integral either by using reduction formula or by using the formula for cos 2 theta. I am solving it by reduction formula. So, when we apply reduction formula, this value is 1 by 2 into pi by 2. When we solve it, this value is pi by 2. It means value of this double integral is pi by 2. That is our answer. You may solve some more examples of this variety. Thank you so much.